All right, what's up, Algebra 2? Here we are with another quick little video to review. This is for the 12.8 quiz review, also useful for test review when we do this standard with the translated trig graphs. Okay, I'll try to stay relatively zoomed in so we can kind of see some details here. Our first one we have is 3 times sine of 1/2 theta minus pi, and I'm going to add a plus 2. I just think we're ready for that. We're ready for that, to have everything kind of going on it all at once. Okay, so after you've done a few of these, you can kind of use, just in your mind here, like the vertical shift, the horizontal shift, and your amplitude to kind of picture about where you need to be. So if I know this is my midline, I'm going to be bouncing 3 up and down. I'm going to be primarily positive, just a little bit negative, and pi to the right. So I'm definitely like quadrant 1 with just a little bit below. So like 1, 2, 3, 1, 2, and then like a couple below here. We should be good. Okay, that should be pretty good for us. I'm going to take care of this plus 2 right away. New midline right there at 2. We're going to be pi to the right, but let's take care of some other things here first. Okay, amplitude is going to be 3. 3. Period is normally 2 pi. We have a half multiplier, so we're going to divide by a half. That's going to stretch our period out to 4 pi. Okay, counting numbers. There are 4 key points, so whatever your period is, you divide by 4. So this is 4 pi divided by 4. We're going to be counting by pi's. So we've got pi, 2 pi, 3 pi, 4 pi, 5 pi. All right. What else can we have here? We have to label this, I guess. This will be a blank on a quiz or a test. Horizontal shift, sometimes called phase shift. Minus pi is actually opposite. When it's in parentheses, we're actually going to go to the positive side or to the right. Pi. Plus 2, we're going to bump everything up 2. We already did that. And we'll come back and get domain and range after we graph here in a second. So we're pi to the right, we're up 2, we're graphing sine. Sine starts on the midline. And then my amplitude is 3, so I'm going to go up 3 on the next spot. 1, 2, 3. And then I'm back down to the midline, and then I'm down 3. 1, 2, 3. And then we're back on the midline. Okay, quiz and a test. You're going to need to label these dots. You're going to need to label these dots. So that's pi, comma 2, 2 pi, comma 5, 3 pi, comma 2, 4 pi, negative 1, and 5 pi, 2. Okay, domain and range. Domain, we're going forever left and forever right. So all the x's are going to be fine. All real. By range, we're going to be continuously bouncing between negative 1 up to 6. No, up to 5. Negative 1 less than or equal to y less than or equal to 5. 5. Not 6, it's 5. All right. Not a bad start, not a bad start. If you need to watch any of that back, go ahead and push pause, rewind, slow motion, whatever you need there. On to the next one. Negative 2 times cosine theta plus pi over 2 minus 1. Okay, so we're down 1, we're pi over 2 to the left. For the most part, we're centered pretty well here, just a little bit back and a little bit down. So I'm going to leave room to go back a little bit. And we're going to be primarily down. That should do us. Okay? minus 1. Let's take care of that right away before I forget. There's my new midline, down 1. Okay, amplitude. Tricky. Amplitude is just 2. It's absolute value of that. 2. Period. No period adjuster. Nice. So it's just a standard. Sine, cosine, secant, cosecant have a standard period of 2 pi. And then our counting, we divide by 4. 2 pi divided by 4 is going to be pi over 2. HS, horizontal shift. Pi over 2 to the left. Okay, VS, we already moved it down 1. We'll come back and get domain and range here in a minute. Okay, we're counting by pi over 2s, and we need to go backwards at least 1. So negative pi over 2, 0. Positive pi over 2, pi. 3 pi over 2, 2 pi. I think we won't need the 2 pi, but whatever, it fits, so we'll use it. Okay, so I'm starting at pi over 2 to the left and 1 down. That's the midline. Cosine normally starts at the top. I'd be up 2, but this is a negative 2, so I'm going to start at the bottom. Okay, and then I'm up on the midline, and in the next spot I'm 2 above the midline, 1, 2. Back down on the midline, 2 below the midline. That's our full cycle. We still have this extra space. Let's just use it. Back up on the midline. Okay, curve. All right. And that's going to keep going on forever, left and right. So our domain is all reals. Our range, we're bouncing back and forth between negative 1, 2, 3 and positive 1. Ooh, quiz or a test. We got to make sure we label these dots. Negative pi over 2, comma, negative 3, 0, negative 1, pi over 2, positive 1, pi, comma, negative 1, 3 pi over 2, negative 3. And that would be your full cycle. This is just an extra spot. 2 pi, comma, negative 1. Okay, so we did a sine and a cosine. We're going to do a secant problem. I can't guarantee that secant's the one on the test. It could be a cosecant, but it's the same idea. Okay? Secant's partner function is cosine. Secant begins with an S, so its partner has to start with the other letter C. If I can get that to stay. So we're going to kind of pretend like we're doing cosine here for almost the whole thing. We're going to start just a little bit to the left and 2 down. So it's going to be primarily in the negatives. So just a little bit to the left and 2 down. Let's see. So it's going to be nearly all negative. So if I do this, and then 2 down, there's my new midline. Okay. Plus pi over 4. Well, we should figure out all the rest of our stuff. Let's figure out the rest of our stuff. Amplitude. Technically NA, because these go up and down forever. So this is technically going to be NA, but we are going to use that too. Period. Okay. Normal period is 2 pi, and we have a 2 times multiplier. So it's going to be 2 pi divided by 2. Means our period is going to be pi. And then counting, whatever that is, divide by 4. So we're counting by pi over 4s. HS, we are pi over 4 to the left, opposite of inside the parentheses. VS, vertical shift, we are down 2. All right, so let's start counting by pi over 4s. I know I need at least one of them over here. Negative pi over 4, 0. Positive pi over 4, 2 pi over 4, reduce that, pi over 2. 3 pi over 4. 4 pi over 4 is pi. And I think that's going to be good enough for me. Just because I've done this problem a bunch before, I know I'm going to need another one. Let's back this up to negative pi over 2. Okay, so now we're going to dot out the cosine part of it. And that's going to help us graph secant. So we're pi over 4 to the left and down 2. Here's our midline that we're starting at. Okay, so if we're doing the cosine, this 2 is kind of like the amplitude for the cosine. So cosine starts on the top. We're actually going to start here. And then midline, and then 2 below, midline, 2 above, midline. Okay, and I said I wanted to use this one because when we do these, right, the midline dots are your asymptotes, and these are going to be parabolas. Bottom side goes down, top side goes up, and you need to have one going up and one going down fenced in between asymptotes. So I backed up once to get that asymptote instead of keep going forward and having to use these two. You could have used these two and then kind of ignored this one, but this was kind of where we started at, so that was kind of important. So you might as well just go backwards a little bit there and get that asymptote behind it. Okay? Labels, asymptotes are vertical lines. So that's x equals negative pi over 2. This is negative pi over 4, comma 0 for that dot. This is an asymptote at x equals 0. This dot is at pi over 4, comma negative 4. And this asymptote is at pi over 2. And we'll stop there. We didn't use those. Domain, kind of a tricky one. Asymptotes are at negative pi over 2, 0, 1 pi over 2. If we would have kept going, this one would have been it. That's 1 pi, or also 2 pi over 2. So it ends up being all the x's that are not equal to the pi over 2's. Everything except the multiples of pi over 2's. Your range is also a little bit tricky because these are split. It's zeros and going up, or negative 4s and down. So we are y's greater than or equal to 0, or less than or equal to negative 4. All right, tangent time. Tangent time. All right. So 2 times tangent, theta minus pi over 2 plus 3. So pi over 2 to the right, 3 up. We're pretty solidly into quadrant 1. We probably don't need anything of any of the others. Okay. And plus 3, 1, 2, 3. There's my new midline. All right. Tangent. Normal period for tangent and cotangent. They're a little bit different. It's just pi. It's just pi. All right, let's not skip steps here, Mr. Handke. Amp NA, technically. And we'll use that too in a different fashion here in a little bit. Period. Okay. Normal period for tangent, we just said is pi. Okay, and we do not have a period adjuster right there, so it's just going to be pi. Okay, counting. Tangent and cotangent are a little bit different there as well. There's only 2 important points for tangent and cotangent. Okay, so that means we're going to take your period divided by 2, because you're either an asymptote or a 0. HS, horizontal, we are pi over 2 to the right. VS, we are 3 up, and we've already done the 3 up part. Okay, so we're counting by pi over 2's, and we are pi over 2 to the right to start with. Okay, pi over 2, 2 pi over 2 is 1 pi, 3 pi over 2, 4 pi over 2 is 2 pi. So here we are, we're starting at pi over 2 to the right, we're up 3. Tangent starts with a 0, or on the midline, and then the next spot's an asymptote, and the next spot's on the midline, and the next spot's on an asymptote. Back it up, this one's an asymptote. Okay? Now, for cotangent, it goes the other way. Cotangent starts with an asymptote, 0, asymptote. Tangent goes up and to the right. Cotangent would go down and to the right. Now, here's where this 2 comes in. Halfway between your 0 and your asymptote, we're 2 up. And that would be, this one's not that bad. Halfway between pi over 2 and pi, or half and 1, would be 3/4. So this is 3 pi over 4, comma. This was 3, up 2 more would make it comma 5. Same thing over here, but down. Halfway between and then down 2. That's pi over 4, comma 1. Halfway between 0 and a half would be 1/4. So pi over 4, comma 1. And then we curve that one out. Domain and range. Domain, asymptotes are 0, 1 pi, 2 pi, 3 pi. It's going to be all the whole pies, all the integer pies. X not equal to multiples of pies. The full pies. Range for these are all real numbers. It goes up and down forever. All right. Next up, a little story problem. Ferris wheel was a common one we did here before the quiz. Don't expect it to be exactly the same on the test, but it's similar. Okay? So for our Ferris wheel, it has a diameter of 250, 30 minutes to do a full revolution, or that's the length of the period, 30 minutes. The lowest we get is 6 feet above the ground. The height at the top of the Ferris wheel represents times 0, the start or the beginning. So they're telling you at the top. We're starting at the top. That's telling me cosine. So just a quick little sketch. Okay, the lowest I am is 6 feet. My Ferris wheel is 250 feet across. Diameter is 250 feet. So that would mean the top, the highest I get, 6 plus the 250 would be 256. So that's my top and bottom. You can use your top and bottom to find the midline. Okay? So you would just like find the average. The average. Okay, 6 plus 256 would be 262. And then you cut that in half, that's 131. That's where your midline is, 131. Okay, and it should also balance out because that should be half of 250. That should be 125 between 131 and the top, and another 125 between 131 and the bottom. And it does, it works out. So that space that you have on the top and the bottom of your midline, that's the amplitude. That's how much you're bouncing around your midline. 125. We said we're starting at the top. That told me we're going to start with cosine. We'll come back to this middle piece in just a little bit. Your midline is 131, so that's a plus 131 on the backside. Okay, we need the period adjuster. I don't think we're moving left or right at all. We're starting right here at times 0. There's no left or right shift, but we do need a period adjuster. Our period equals 2 pi over your b multiplier. And that's what we're trying to find, the b multiplier that sits there next to theta. I know what I want my period to be. I want that period to be 30 minutes. So 30 equals 2 pi over b. Let's solve for b. Okay. The b goes up, the 30 goes down. 2 pi over 30 would reduce to 1 pi over 15, and that is your theta multiplier. So we're going to have pi over 15 times theta, like that. Okay, or if you had the pi over 15 parentheses theta, the pi over 15 is your period adjuster, your multiplier on the inside. Okay, and that'll do it for you. All right. It might be a Ferris wheel related one. It might not be a Ferris wheel related one, but very similar. Okay, very similar. Let's see if I got another one here for you. We talked about like in the winter, you know, and we're constantly varying between, or like not maybe late winter, early spring, where the snow melts and then it snows, and the snow melts and it snows. And we're constantly bouncing back and forth between like 2 inches of snow up to 8 inches of snow. All right, and it just keeps bouncing back and forth repeatedly, and that pattern repeats every, like, let's say repeats every 4 days. Okay. And you want to start with 8 inches on the to start with. So that would mean we're starting with cosine. Okay, so now we have the high and the low. We didn't have to do a diameter thing like we did in the Ferris wheel. It told us what the high point and the low point were. So our midline here, halfway between 2 and 8, would be 5. That's where my midline is. Then my amplitude would be 3, because that's the difference between 5 to 8 and 5 to 2. So 3 cosine, then the middle part, plus 5. Repeats every 4 days. That's the period. So 4 equals 2 pi over b. b equals 2 pi over 4. That's pi over 2 in here next to theta. All right, so something like that. So if you have this process down for the Ferris wheel stuff, you should be okay. All right. If you thought you were going to kind of carbon copy and just memorize Ferris wheel, and just you might be kind of in a tough spot, because it might be something a little bit different, same process, but just worded a little bit different, okay? So let's make sure we really know what we're doing. Find the high point and the low point. Use that to get your midline and your amplitude, and then look at what you need to do for your period adjuster. All right, thanks, kids. Hopefully this helps. We'll see you guys later. Good luck on your quiz and or your test.